4 parts with ROM 4001, RAM 4002, shift registers 4003, and CPU 4004. To an unnamed woman from the Nara Women's College present at a brainstorming meeting that was held in Japan prior to his first meeting with Robert Noyce from Intel, leading up to the Bisicom deal. 38. The 4004 is part of the MCS4 family of LSI chips that can be used to build digital computers with varying amounts of memory. The other members of the MCS4 family are memories and input forward/output circuits which are necessary to implement a complete computer. The 4001 is a ROM, read-only memory, with 4 lines of output. The 4002 is a RAM, random access memory, with 4 lines of input forward/output. The 4003 is a static shift register to be used for expanding the I forward/O lines, for example, for keyboard scanning or controlling a printer. The 4004 includes functions for direct low-level control of memory chip selection and I forward/O, which are not normally handled by the microprocessor. However, its functionality is limited in that it cannot execute code from RAM and is limited to whatever instructions are provided in ROM, or an independently loaded IN working as ROM. In either case, the processor is itself unable to write or transfer data into an executable memory space. The RAM and ROM parts were also unusual in their integration of output, and, in the ROM's input ports that significantly reduced the minimum part count in an MCS4 system, but required inclusion of a certain amount of processor-like logic on the chips themselves to accept, decode and execute a relatively high-level data transfer instructions. The standard arrangement for a 4004 system is anything up to 16 4001 ROM chips in a single bank, and 16 4002 RAM chips in 4 banks of 4, which together provide the 4 kilobytes program storage, 1024 plus 256 nibbles of data forward/status storage, plus 64 output and 64 input forward/output external data forward/control lines, which can themselves be used to operate, for example, a 4003. Intel's MCS4 documentation, however, claims that up to 48 ROM and RAM chips, providing up to 192 external control lines, in any combination can be connected to the 4004 with simple gating hardware, but declines to give any further detail or examples of how this would actually be achieved. Technical.
Yes, sorry. I got my cell phone. I had something I had to reply. I lost, cannot follow the text at the same time because it's reading so fast. I had to reply something important on my cell phone. Let's get some cola. I have to continue my normal life. I try to continue. Same time I do all these videos. That take a lot of time in my life, and sometimes I have to do something. Somebody knocking on my door. I have strangers, because I'm a YouTuber, I'm a famous YouTuber. I have strangers coming to my home and knocking on my doors and windows and shouting and stuff. But I have secret phone number, of course. So, but somebody, that's why if somebody write to me. Because that's important that some people I know, like my family or somebody I know. So I had to reply, and I spent 10 minutes to this SMS. So I lost the text because I cannot type same time and read. So, but this is why I do like this. Sorry. Yes, that can happen. I just stop this text because I need a small break because that's too much information. But this actually helps me That helps me to understand, but I cannot do something else at the same time. I cannot SMS on my cell phone same time, like 10 minutes, and same time follow what's reading. So I lost a part of the reading because I have to pay my attention to this cell phone. And actually, I like to read this. No, I like to read it. But I already read it long time ago. No, not long time, yesterday. But I understand it much better when somebody read it loud that actually read real English. Yes, and the first video is public. Yes, I'm recording with this old JVC camcorder because I can do like this, and the microphone is good and it can record very sharp. That's my only camcorder can do like this. It can record text very clearly. So I use this camcorder to read, to copy on, to record video from the screen. Yes, that can happen, and then I think I just need to pause when something happens. But I cannot just pause the reading like 10 minutes, say, okay, sorry, I have to get a break 10 minutes. Because I have to reply on my cell phone. Or somebody knocks. This is why normally I close this door to my living room, because I could have strangers coming, knocking at my doors or windows. Not every day, but that happens 200 times. So that's not nice to have strangers. That's young male teenage boys and young males do that. That's never a woman. That's not a lot of young women coming knocking on my door with wine and tell me let's drink some wine or do something. That's not the female. That's the young males do that, and teenage boys. That's only them knocking. So yes, but we got to there, and let's just continue. Actually, that helped me a lot, but I lost a bit some text there because I have to pay attention to this cell phone. So let's try to continue. So sorry for that, but I have to try to continue my real life. Yes, continue.
Specifications. 2C4004 DIPS, with one open to show the die Intel 4004 architectural block diagram. Maximum clock rate is 740 kHz. The 4004 had this maximum clock rating upon its initial 1971 release. Note 1. Instruction cycle time, minimum 10.8 s. 34, 8 clock cycles per machine cycle. Instruction execution time 1 or 2 machine cycles, 10.8 or 21.6 s, 46,250 to 92500 instructions per second. Adding 2 8-digit decimal numbers, 32 bits each assuming 4-bit BCD digits. Takes a claimed 850 s or approximately 79 machine cycles, 632 clock ticks, for an average of just under 10 cycles, 80 ticks per digit pair, and an operating speed of 1,176 8-digit additions per second. Note 2. Separate program and data storage. Contrary to Harvard architecture designs, however, which use separate buses, the 4004, with its need to keep pin count down, uses a single multiplexed 4-bit bus for transferring 12-bit addresses. Intel 4004 DIP chip Pinute Intel 4004 registers 111009080706050403020100. Bit position Accumulator condition code C carry flag index registers R0, R1, R2, R3, R4, R5, R6, R7, R8, R9, R10, R11, R12, R13, R14, R15 program counter pushdown address call stack PC1 call level 1 PC2 call level 2 PC3 call level 3 8-bit instructions 4-bit data words able to directly address 5120 bits, equivalent to 640 bytes, of RAM, stored as 1284-bit characters and organized into groups representing 1024 data and 256 status characters, 512 and 128 bytes. Note 3. Able to directly address 32,768 bits of ROM, equivalent to and arranged as 4096 8-bit words, i.e. bytes. Note 4. Instruction set contained 46 instructions, of which 41 were 8 bits wide and 5 were 16 bits wide. Register set contains 16 registers of 4 bits each. Internal subroutine stack, 3 levels deep. Logic levels. Symbol min.max VSSDD plus 15V 5% plus 15V plus 5% VILVs 5.5 VIFs 1.5 VVSS plus 0.3 volts 12 VVSS 6.5 VOVs 0.5 VVSS. Support chips. 4001. 256-byte ROM, 256 8-bit program instructions, and 1 built-in 4-bit I/O port. A 4001 ROM and I/O chip cannot be used in a system along with a 4008/4009 pair. 39. 4002, 40-byte RAM, 84-bit data words, and 1 built-in 4-bit output port. The RAM portion of the chip is organized into 4 registers of 24-bit words 16 data words, used for mantissa digits in the original calculator design, accessed in a relatively standard manner. 4 status words, used for exponent digits and signs in the original calculator design, accessed using I/O type commands in place of the ROM's input channel. 4003, 10-bit parallel output shift register for scanning keyboards, displays.
Yes, short break, sorry, because I forgot to put my first video public. It's Sunday, so let's do it. Yes, I did drink too fast. So I'm just an old YouTuber, try to make some videos. And I need a shower and a shaving. But now I spent a lot of time to do this. Let's put this video public because maybe somebody like to watch it. I don't have many subscribers and maybe this kind of video could help me to get some more subscribers. That's not from Denmark. So let's just try to put it public. And now it's public, but I have to remember like this one be in many parts. I have to remember to write how many parts it is, so they can, if they like to read it, they have to go to my playlists. So let's just, actually this is very helpful, but I cannot reply my cell phone same time and SMS. I cannot sit SMS my cell phone like 5 or 10 minutes because then I totally lost where this text is reading. I was able to find the text again, but I will maybe not be able to do that again. So I think I have to pause the text because there's a lot of numbers and information and I cannot just spend 10 minutes to check something important, my cell phone. I have to reply 5 or 10 minutes. Then I totally lost where we are reading. I cannot find it because actually I like to read this myself. So this could maybe be helpful. We are somebody around here, so I will just start. But let me check my cell phone again. If I have to reply anything, no. No, I don't have to reply anything now. Now, let me get a little bit more cooler. And that's a little bit hot in my living room because the sun is shining into my living room. But that's good, that's spring and we have the summer next month. Yes, let's continue.
Printers, etc. 4008, 8-bit address latch for access to standard memory chips and one built-in 4-bit chip select and I/O port. 4009, program and I/O access converter to standard memory and I/O chips. 4269, keyboard/display interface. 4289, memory interface, combined functions of 4008 and 4009. The minimum system specification described by Intel consists of a 4004 with a single 256-byte 4001 program ROM. There is no explicit need for separate RAM in minimal complexity applications thanks to 4004's large number of onboard index registers, which represent the equivalent of 16 4-bit or 8 8-bit characters, or a mixture of working RAM, nor for simple interface chips thanks to the ROM's built-in I/O/alleles. However, as project complexity increases, the various other support chips start to become useful. Packaging. Numerous versions of the Intel MCS4 line of processors were produced. The earliest versions, marked C, like C4004, were ceramic and used a zebra pattern of white and gray on the back of the chips, often called gray traces. The next generation of the chips was plain white ceramic, also marked C, and fended gray ceramic, D. Many of the more recent versions of MCS4 family were also produced with plastic, P. The ceramic C4004 variant without gray traces. The ceramic D4004 variant. The plastic P4004 variant. Use. The first commercial product to use a microprocessor was the Bizicom Calculator 141PF. The 4004 was also used in the first microprocessor-controlled pinball game, a prototype produced by Dave Nutting Associates for Bally in 1974. In 1996, the U.S. Patent Office officially recognized Mr. Gary W. Boone and his employer, Texas Instruments, as the inventors of the single-chip microcontroller, overturning the patent grant to Gilbert P. Hyatt in 1990. Even though the patent had expired, it was thought to have potential financial impacts depending on the details of previous contracts with Gilbert Hyatt. 40, according to Nick Tredenick, a microprocessor designer and expert witness to that Boone/Hyatt patent case. Here are my opinions from the study I conducted for the patent case. The first microprocessor in a commercial product was the 4-phase Systems L1. The first commercially available, sold as a component, microprocessor was the 4004 from Intel. 41, a popular myth has it that Pioneer 10, the first spacecraft to leave the solar system, used an Intel 4004 microprocessor. According to Dr. Larry Lasher of Ames Research Center, the Pioneer team did evaluate a 4004, but decided it was too new at the time to include in any of the Pioneer projects. The myth was repeated by Federico Fagin himself in a lecture for the Computer History Museum in 2006. 42, Legacy and Value. In the lower right corner of the CPU are the initials FF. Federico Fagin signed the 4004 with his initials because he knew that his silicon gate design embodied the essence of the microprocessor. A corner of the die reads FF. 37, on the 15th of November, 2000.